In this lesson, we're going to move from 2D shapes to 3D shapes and talk about volume. Volume is going to be the measure of the amount of space inside a 3D figure. So you're going to only be able to calculate volume with a 3D figure. So let's talk about the volume of prisms first. The volume of the prism is the product, so remember that means to multiply, of the area of the base and height. So we're going to be multiplying the area of the base times the height. So when we take a look at the figures below, so we have two prisms. The first one on the left is going to be a rectangular prism. So finding the area of your base, and you can see that base is shaded for you. So you want to find the area of that, which would be length times width, because that's going to be a rectangle. Then when you look at the prism on the right, that's a triangular prism. So a triangular prism, your base is a triangle. So to find the area of that triangle, you use the area of a triangle formula, 1/2 base times height. So your formula for volume is volume equals a capital B times H. And we use a capital B because that stands for area of the base. Okay, the capital B, a lowercase b is just base. Capital B is area of the base. So let's jump into some examples. Number 1, we have a rectangular prism. My base here is a rectangle. So we're going to set up our work area. So area equals, or volume equals area of the base times the height. So let's work on finding the area of your base first. So our base is a rectangle, and the area of a rectangle is length times width. And for this particular rectangle, length and width are 7 times 9. And we know 7 times 9 is 63. So again, we're looking at the base down here at the bottom. Then we need to know what the height is. So our height is going to be the height of the whole rectangular prism. So this is our height, 6. Remember, height goes straight up and down. It's going to come straight up off of your base. So our height is 6. So volume is going to be 63 times 6. So we took the area of our base, 63, times our height, 6. And that's where we got 63 times 6. And we can do this by hand, or we can put it in the calculator, and we find that 63 times 6 is 378. And since we're talking about volume, our unit of measure is yards, and that's going to be cubed. So volume, our unit of measure is yards cubed. So remember, perimeter would just be yards, area is yards squared, volume is cubed. Go ahead and highlight number 2 and 3, and let's look at number 4. So number 4, I still have a rectangular prism, but if you notice, some of my measurements are fractions. So I'm going to find the area or the volume the same way. Volume equals area of the base times the height. And then I'm going to break it up, and I'm going to find the area of my base, which is a rectangle, and I know that is length times width. So when I look at that shaded part, my base, my length and width are 9 1/8 and 5 3/4. So we're going to multiply 9 1/8 times 5 3/4. And we can do that in our calculator. And that would give us that would be 9.125 times 5.75. That gives us 52.47. And then our height, the height of the whole thing is going to be 4. So then we're going to multiply that 52.47 times 4. So volume is going to be 52.47 times 4. And that would give us, we're going to put that in our calculator, that would give us a volume of 209.88, and it's meters cubed. Because again, volume is going to be cubed. Now, let's take it, those were some rectangular prisms. On the next page, we're going to look at triangular prisms. So that means the base of our triangle is, or the base of our prism is a triangle. So if we take a look at number 5, our base is here. And we find the volume the same. It's the same formula. The area of the base times the height. So if we divide it up, the only difference is when we find the area of the base, our area is a triangle. And we know that area of a triangle formula is 1/2 base times height. So just finding the area of the base is a little bit different. So that would be 1/2 times, so remember your base and height of your triangle form your right angle. So the base and the height are 5 and 12. Because they come together here to form this right angle. So then when I multiply that, I know 5 times 12 is 60, and 60 times 1/2 is 30. And then your height of your prism is what holds your two bases separate. So for this one, our height is 3.8. So then we're going to take the area of our base times our height, because volume is area of the base times the height. So 30 times 3.8. And we can put that in our calculator, and we get 114. And that is, we're talking about inches, and since we're talking about volume, that's inches cubed. Go ahead and highlight number 6, and you can go ahead and highlight 8. We're going to look at number 7. So number 7 is also a triangular prism. Number 7 is one of the shapes where it's tempting to say that our base is this rectangle, but it's not. So your base is not always what your shape is sitting on. So you have to have two bases. So your bases are going to be the two faces that are parallel to each other. So I can see I have a triangle back here. And then moving forward, I have another triangle here. So these are our two faces that are parallel to each other. So our base is that face. So we're going to find the area of the base and then multiply it by our height, because that's our volume formula. So our area of a triangle, because a triangle is our base, and the area of a triangle again is 1/2 base times height. So that's 1/2 times 7 times 5.5, because again we're just looking at this triangle here. So when I multiply that, 7 times 1/2 times 5.5, I get 19.25. and then your height. So it's the height of your prism. So the height of our triangle is 5.5. That's what we used when we found the area of the base. The height of the prism, remember, is the side that connects your two bases. So the height of my prism is this 14. So back to volume, area of your base times your height. We found the area of our base is 19.25 and our height is 14. So when we multiply those two together, we get 269.5, and our unit is meters, and it is meters cubed. And then go ahead and take a look at, there's a few application problems. So number 9, the bed of a dump truck has dimensions shown below. The truck is delivering salt to a city in preparation for a snowstorm. If the city needs 800 cubic feet of salt, how many trips will the truck need to make? So the salt is what is holding inside of the truck. So that's what makes this a volume problem. It's how much inside the truck can hold. And what you're going to have to do is find the volume of the prism and then compare it to how much salt they need and figure out how many trips they would have to make. If they only need 800 feet, they would only have to take, if the truck held 800 feet, they would only have to make one trip. So think about comparing that volume to how much salt they need. Go ahead and highlight number 9. So it's not just a straight volume problem. You'll have to take that volume and apply it. Number 10, Bethany has a bottle of perfume in the shape of a triangular prism. What is the maximum amount of perfume the bottle can hold? So we have our figure, and that's what the bottle looks like, that shape. And it wants to know how much it can hold. So filling up that prism, how much it would be. So that would be a straight volume problem. So highlight number 10. And number 11, John's in-ground pool is in the shape of a rectangular prism with the dimensions shown below. If the pool is only 80% full, find the amount of water. So number 10, we found how much perfume it would hold because it holds it all the way to the top. Well, the swimming pool only goes 80% up. So what you're going to have to do is find the volume of the whole pool and then find 80% of that. So it's like number 9 where you have to find the volume and then use the volume. Go ahead and highlight number 11.